So our first speaker is Nour-Eddine Kaikai from Kadi Ayad University in Morocco. And his talk is entitled Hippocampal Neuroinflammation and Cognitive Impairment Following Chronic Exposure to the Pesticide Metam sodium in Adult Mice. So this talk is pre-recorded. So after the video, he will be on to answer questions live. So feel free to ask questions in the chat during the talk.
Good evening, everyone. Glad to be here with you in this event. My name is Nour-Eddine. I'm a PhD student at Kadi Ayad University from Marrakesh, Morocco. As you notice from the title, my work fits into the field of neurotoxicology. As you may know, great interest has been attributed to the involvement of environmental toxicants, such as pesticides, in the occurrence of disorders affecting the integrity of the brain. Given the magnitude of the problem and the potential for subtle damage to the nervous system, it is urgent to assess the behavioral and neurological effects of the mass of chemicals present in different workplaces and in our surrounding environment. And actually this is the basis that drives our work here. So please let me first start with a general overview on pesticides. As you may know, pesticides are used extensively in almost all areas given their beneficial effects, such as they ensure sufficient food production, protection of crops from pests. They also ensure a regular harvest and an economic yield. However, over the years, their use has resulted in several harmful effects affecting both humans, animals, and the environment. In fact, several studies have shown a strong association between the use of these chemicals and the occurrence of carcinogenicity, for example, endocrine and reproductive effects, and a wide range of neurological and neurobehavioral abnormalities. Given the fact that they are ubiquitous, different groups of population are exposed to pesticides, but in unequal and diverse ways. In some cases, exposure is deliberate, so here oral exposure to high doses leading to severe intoxication and death is generally the route used for suicidal and homicidal reasons. We also have accidental exposure, where exposure can occur by the oral, dermal, or inhalation routes. In this case, there is an occupational exposure in the workplace, so here we're talking actually about workers, about professionals that are involved in the production, transport, mixing, loading, and application of pesticides. So this category actually presents the greatest risk of exposure to these chemicals, and they are usually exposed to high doses during a short period of time. Finally, we have non-occupational exposure, which I think is more serious. Here we're talking about the general population who consume low doses as pesticide residues in food or as contaminants in drinking water for a long period of time, probably throughout our lifetime. One of the emergent pesticides that are widely used is Metam sodium, which is our chemical of interest here in this presentation. So MS, Metam sodium, is an organosulfur dithiocarbamate compound. It is active against all living matter in the soil, so it can act as a fungicide, as a herbicide, as a nematicide and insecticide simultaneously. In 2002, more than 24,000 tons of MS were used in the United States alone, and it was ranked third on the EPA list of conventional pesticides most commonly used in the United States agricultural production. And since methyl bromide, which is a similar pesticide that was completely phased out just recently, we can assist to a further increase in the global use of Metam sodium in the years to come. The capacity of MS to induce reproductive and neurotoxic effects has been well documented. Actually, several epidemiological data showed that exposure to this biocide is associated with cases of depression, anxiety, pain, memory impairment, and so on. However, none of these studies assessed the consequences on the brain and behavior. We have previously shown that maternal exposure to MS induced a wide range of sensory-motor and behavioral abnormalities in the offspring associated to oxidative stress. However, these effects that we have observed, they occurred following in adulthood, in offspring during adulthood, following an indirect exposure. So we wondered here whether these alterations would happen following a direct exposure during adulthood, which is specifically actually on learning and memory, which is the aim of our presentation here. And we are also interested in neuroinflammation as an underlying possible mechanism. So to do so, animals were subdivided into 4 groups. The control group that didn't receive Metam sodium, and 3 MS exposed groups. These groups received chronic administration during 90 days daily via intragastric gavage. The behavioral testing started the day after the last administration and consisted of 2 tests: novel object recognition test and strep-through passive avoidance test. So the novel object recognition test is a relatively fast and efficient mean for assessing recognition memory in rodents based on their spontaneous behavior to explore novel environments. The test relies on 3 main sessions that were conducted over 2 days. The habituation session that was conducted during the first day is dedicated to the free exploration of the device by each animal for 10 minutes in the absence of any object. In the training session, 2 similar objects were positioned in the back part of the arena, and animals were allowed to explore the objects for 5 minutes. The test session is then started after 1 hour, during which one of the similar objects was removed and substituted by a different one. Then each animal was allowed to explore the 2 objects, the familiar one and the novel, for a 10-minute period. During this session, the time spent beside the novel object and the discrimination index were calculated. Our results showed that all exposed animals to 3 doses spent significantly less time beside the novel object, and consequently they exhibited a reduced discrimination index between the 2 objects, which indicates that recognition memory is altered following exposure to metam sodium. The following test was a passive avoidance test. So this test is a one-trial learning paradigm during which mice form an association between an aversive stimulus and an environment where the stimulus was received. So the apparatus consisted actually of a plexiglass device with two compartments with the same dimensions, an illuminated compartment and a dark one, separated by a gate door allowing free passage of mice between the two compartments. The dark compartment was equipped with an energized grid floor related to an electric shock generator. This test lasted 3 days. During the first day, the gate door was open and all animals were habituated with both compartments of the device for 3 minutes. During the second day, each animal was placed again in the bright compartment facing the closed gate door. After 10 seconds, the gate door was opened, and once the animal crossed the dark compartment, the gate door was closed again, and a single electric foot shock during 1 second was immediately administered. After shock administration, the test phase was conducted 2 hours and 24 hours later, corresponding of course to short and long-term memory respectively. During each test session, the time needed to reach the dark compartment with all 4 pose was recorded, and for a maximum duration of 5 minutes. So our results showed that all treated animals, especially by the highest doses 100 and 150, entered more quickly to the dark compartment after the food shock administration, either 2 hours or 24 hours later, which indicates that short and long-term memory are impaired following exposure to metam sodium. So after this, we have evaluated neuroinflammation by immunohistochemistry as an underlying mechanism of these cognitive defects. We used GFAP and Iba-1, which give an idea about astrogliosis and microgliosis, respectively. So animals were perfused and brains were removed then sectioned. Free floating sections containing hippocampus were used in IHC, immunohistochemistry, given the key role of this brain region in learning and memory. Regarding astrocyte marker GFAP, our results showed a high expression of this protein within all subregions of the hippocampus, either in dentate gyrus, CA1 and 3 of the hippocampus, especially in animals treated with the dose 50 and 100 mg per kilogram of MS. As for Iba-1, all treated animals showed a high Iba-1 immunoreactivity, which suggests a microglia activation within subregions of the hippocampus. So to sum up, following a chronic exposure during adulthood to metam sodium, we demonstrated that this exposure induced some cognitive impairments presented by an alteration in recognition memory and a short and long-term memory evaluated by novel object recognition and step-through passive avoidance test respectively. We have also shown that these cognitive impairments might be associated with the induction of neuroinflammation following excessive expression of GFAP and Iba-1 proteins that mark astroglia and microglia respectively. Neuroinflammation may indicate the existence of more and profound neuronal damage at the level of the hippocampus, whose functional integrity is necessary for the normal acquisition of information, including the detection of new events, locations, or stimuli, and the association between them. So thank you again for this opportunity, and thank you for your attention.
So I will just repeat the question, what was asked. Okay, sorry. So yeah, we're just going to repeat that question. There was just a bit of an issue. Sorry about that, Nour-Eddine. So I'll just repeat the question just for the viewers. It was Alexis Bouatois was wondering what kind of control groups were used for the experiments to be sure that the effects of the chemicals were actually, or that the effects were actually, or sorry, that the chemical affected learning and memory and not something else such as locomotor or vision. So Nour-Eddine, can you just do a quick recap of what your answer was?
Yeah, all right. So the control group actually underwent the same conditions as the treated groups, using the same vehicle where Metam sodium was dissolved, which is tap water, and the same route of exposure, which is gavage. As for locomotor activity, so I think you talked about locomotor activity. There was, before behavioral testing, we started actually with the open field test, which didn't.
Oh, I think we froze a little bit. Sorry, you're back on, go ahead.
Sorry about that. Which didn't show any difference between the treated animals and the control group, either in the distance traveled and the velocity.
Okay, great. Thank you for summarizing that. So we don't have any more questions in the YouTube chat, but I do have one question. At the beginning, you talked about how methyl sodium is used to replace methyl bromide because that one was phased out. So why was methyl bromide phased out? Is it more dangerous than MS?
Yes. Sorry, can you please?
Yes. Sorry, one of the other questions was, you mentioned in the introduction that methyl bromide was phased out and MS has been adopted to replace it. So why was methyl bromide phased out? Was it more dangerous compared to MS?
No, actually, it's an environmental issue. Actually, it is related to the ozone problem, so that's why it was phased out. and it was replaced by Metam sodium because this Metam sodium is more effective. There's more efficacy, and the price was low.
Okay. Okay, thank you. And we do have time for one more question, which is, again, in the introduction, you talked about a number of effects of MS on behavior and neurocognition and everything. Are any of those studies in humans, or are they all in model organisms?
Actually, they are epidemiological studies. So they were observed. They were actually clinical cases that were observed following accidental exposure to Metam sodium. So there was actually a famous accident in California where a huge quantity of MS was spilled into a river, and the people living around that river suffered from several cases of depression, anxiety, and pain, locomotor, motor activity problems. So we based our study on these observations to conduct an experimental one on mice and to see whether exposure in mice would lead to such effects.
Okay, so that's kind of what led to the research. Okay, great, thank you. So we don't have any more questions on the YouTube chat, but again, people are free to ask questions on Discord as well.